Hello everyone and welcome to this new video. My name is Dr. Karachi and today I'm going to talk about working principle of major wireless network. Now, today in this video, we're going to talk about the classification wireless network, wireless wide area network, wireless metropolitan, wireless local area network, and wireless PAN as a personal area network. Now, classification of wireless network can be divided into four major categories, which is all based on the coverage area, different protocols used, different standards, and different frequency bands and technologies involved in these four categories. Now, the first one here, we're going to talk about the wireless area, the wireless wide area network. It operates in a very large coverage area of hundreds of kilometers or even more. It uses satellite or microwave network between two or more cities or even region. Now, the wireless WAN can be classified into two major categories: point-to-point wireless WAN and the switch wireless network or cellular network. Now, in the point-to-point wireless WAN, it's often used as satellite links between two remote area, as you see it over here. Okay, and usually a subscriber will use these links to access data service or even ISP to establish transmission. You could see this type of things, like a small dish like this, especially like in the rural areas or in the mountains, an area where it's impossible to have a fiber optic cable connection. Now, uh, in a point-to-point wireless WAN, if a satellite is synchronized with the Earth's orbit, it is commonly referred to as geosynchronous. The communication satellites used for the commercial use of point-to-point internet connectivity are normally operated in the Ka and Ku bands with the microwave signals. The microwave frequency used for the Ku band, for example, is 12 to 18 gigahertz. The frequency range for the Ka band microwave is 26.5 to 40 gigahertz. So this is just a very good example of the point-to-point connection, which includes satellite internet links and microwave backhaul communication links. Now, in this picture over here you could see that the satellite can communicate through microwave signals to wireless antenna unit called the VSAT. Now, uh, this type of antenna is designed for satellite internet point-to-point links. Usually, the size of the VSAT antenna can be as small as 75 centimeters in diameter and as large as 3.8 meters in diameter. But in standard satellite ground station communication, usually the maximum size of the VSAT, especially for internet connectivity, it's about 1.2 meters for diameter at the maximum. Now, these small antennas are usually two-way communication ground stations that can receive signals, received from the satellite and are connected to the network service providers. And those links communicate with the local ISP. Okay. And again, where to find these type of things? In the remote areas in the countryside. Now, the microwave backhaul links are type of point-to-point communication, okay, and used to establish connectivity between two terrestrial stations on Earth. Now, this type of communication is used for backhaul and inter-site communication for telecom systems. Usually, the backhaul systems are used to transfer data between cities and countries. Now, a good example of backhaul communication system powered by microwave relay or repeater system are very common in the United States, Europe, and other countries. Now, This type of backhaul microwave communication network is also known as a global microwave relays or links, commonly used in the backbone and cellular communication system. You know, the microwave system use microwave antennas, which are narrow, okay, beam directional antenna, as you see here in this picture, to keep transmitted signals focused and directed to the target receiver antenna of the same type. Now, both sending and receiving antennas should be directed accurately to each other for communication. Now, the microwave wavelengths fall between 1 meter and 1 millimeter, and their frequencies range between 300 megahertz and 300 gigahertz. Okay, now the microwave frequency offer higher data transmission bandwidth, making them suitable for high bandwidth transmission lines between cities and countries. The effective range of this type of microwave links is about 64 kilometers, and the taller towers are needed for loss of signal adjustment beyond this range due to the Earth's curve. Now, a microwave communication link between two sites consists of the following here, functional hardware infrastructures. Now, the first one is the transmitter of the signal here. Okay, so the transmitter of the signal is a device that converts the information to be transmitted, such as voice, data, video into microwave signal. Okay, and that can be transmitted through the air. That's why here, if you see it, as we discussed previously, it's a point-to-point link. Okay, now the transmitter typically amplifies the and modulates the microwave signal to improve the strength and quality. Now, the waveguide media, it's basically can be any type of cable that carries the signal from the transmitter to the directional antenna. Okay, now the third one, directional antenna of a suitable size. It depends on the type of microwave. Yeah, basically here, the antenna focus the signal in a specific direction, as you see it in the picture here, from this location to that location, allowing it to be transmitted over a long distance. Now, the receiver of the signal. Okay. Basically, this is a device that receives the microwave signal transmitted by the transmitter and converted back into original format. Okay. So the receiver typically amplifies and demodulates the microwave signal to extract the original information. Now, quite frankly, the microwave communication is being gradually replaced by, of course, the fiber technologies, which offer much better benefits than microwave communication system. However, it's still being used when installing fiber cable is very costly or unrealistic in the remote areas of the countryside. Now, a complete cellular network to work as a wireless WAN, it needs these following components. The first one is number one, an integrated network of wireless base stations. Okay. Now, these are the radio transmitters and receivers that provide wireless coverage to mobile devices here. Okay. They are known as the cell site, as you see it in the picture here. This is the cell site. Now, the back-end connectivity between the cellular base stations, okay, this refers to connectivity between the various cell sites in the network. They have to communicate together. This allows for seamless handoff, like when you drive from this point to this point while you're making phone calls. Okay, this type of back-end connectivity allow you to continue making calls without being dropped. Okay, Now, so the other one, what we call it, the BSC. Okay. Now, the BSC here, the base station controller, as you see it in the picture. Okay. This is the central hub that manages the communication between the cell sites and the mobile switching center, MSC. Okay. Uh, the backhaul connectivity provides basically the connection between the BSC and the cell sites. Now, uh, number four, it talks about connectivity from BSC to MSC. Now, the MSC here in this picture is the main hub of the cellular network that manages the call routing and other network functions. The BSC, okay, basically communicates with the MSC, okay, uh, to connect mobile devices to a wider network. Now, the location registers, okay, these are databases that store information about the mobile devices and their current location. Now, the home LR, which is location registers, stores information about the mobile device home network, while the visitor LR information about the mobile's current network. Now, also here you have the user authentication and equipment identity database. Now, these are databases that store information about the mobile devices and their users. They are used to authenticate the user and the device to ensure that only authorized devices are allowed into the network. And finally, here we have the gateway data server. Okay, the gateway is a server that provides connectivity to a wider internet and other network here. Okay, it is responsible for routing data traffic between the cellular network and other type of network. Okay, so now the cellular network is technically divided into subsystem. Here there are three major subsystems without including the mobile station here. Now, the figure represent GSM architecture elements here. The GSM network has actually it has four separate parts, which is, we should always include the mobile device itself, here. So the first one here, we have the base station subsystem, okay, which deals with the BTS. If you look at the here, this is the BSS system. That's the base transceiver. This is the BSS system. Okay. Now, it has BTS, base transceiver station. Okay, and it has BCS, the base station controller. So the BSS deals with these components over here. Now the BTS sends and receives signal, as you see the BTS receives signal from the mobile devices through radio signals. Then the BTS sends the radio signals to the BSC, the base station controller, for connecting to authentication, switching, or even to other network. Now, here we have the network switching subsystem, NSS. This is the core network. It tracks the location of the callers to enable delivery of the cellular services. Now, the NSS has a different parts here, like the MSC, which interacts directly with the BCS here, you know, and basically, the mobile switching center, as an example, here you have the home location register. Okay, here HLR, and the visitor location register right here. And finally, the AUC for authentication and for ciphering on the radio channels. Now, these components perform different functions, such as routing calls, short message services, SMS, authentication, storing caller account information via SIM cards. And finally, here we have the operational subsystem, which basically, this is in charge of the operation and maintenance of the entire network, management of the database of device identification, and authorization of users, with the help, of course, with the NSS here, coordination. So basically, it is used to control and monitor the overall GSM network. And it is also used to control the traffic load of the BSS. Okay. Now, you might be asking, how do calls happen in GSM architecture? This is very simple architecture. You can see it over here. When making a call, the process involves several components of GSM network architecture. The subscriber sends a call request to the MSC, okay, which is the mobile base center. Now, this call, this call request is sent through what? The BTS, the tower and the components, and or what we call it, the base transceiver station, and the BSC equipment, which is the base station controller, the things we discussed it previously. And eventually it's going to be routed to the MSC, okay, and the mobile base center, which verifies the credentials of the subscriber and determines whether the call is local or roaming. Now, once the subscriber is being verified, the MSC sends the request to allocate the voice or the traffic channels to the subscriber. Now, the request will go back to the BSC, which tells the BTS to assign specific channel for the user here, in order for the user to communicate. You know, so in the same time, by the way, the MSC sends a request to the BSC of the destination number to whom the caller or the subscriber wants to talk. And the request is sent to allocated channel for the call. Now, once both the BSCs respond with the allocated channels, okay, that means that they assign you a channel. The MSC switches the call to establish ringtone to the called subscriber. Now, when the call subscriber receives it, receives the call, the channels are allocated for voice communication to take place. Now, this process enables the establishment of a mobile call and allocation of the necessary resources for successful communication. Now, let's look at the wireless metropolitan area here. Okay. Now, smaller than wireless WAN and it's larger than wireless LAN. Maximum coverage area is about 30 kilometers in diameter. The coverage area of the wireless WAN ranges, up to entire campus of multiple LANs connected to it. Now, what are some of the features here? It's normally a relatively bigger network spread across a city or like large campus, with multiple small wireless LANs connected to it. It ranges up to 30 or even 50 kilometers. It may include many LANs and PANs. It can it can be point to point as well as point to multiple point network. It's usually it could be owned by ISP or government organization or even private organization. Now, the large coverage area put the wireless man at a bigger risk, by the way, of security and privacy breaches committed by hackers. Now, the WiMAX was developed for an area where fiber optics or copper cables were unavailable. It's very similar to Wi-Fi concerning internet access through the router, and it's referred to as a 3G. The standard by IEEE is 802.16, which is known as a broadband wireless access. The coverage range of the fixed WiMAX is about 3 kilometers radius. The average bandwidth offered by this technology was in the range of about 15 to 40 megabit per second. And it is basically the WiMAX works with the lower two OSI layers of communication, which is the physical layer and the data link layer. Now, here we have the LTE, long-term evolution, referred to the 4G. Now, the use of LTE, advanced technology, it's highly widespread in North America, South Africa, and many other countries. The big competitor of LTE advanced technology is the fifth generation, which is the 5G, okay, which was introduced back in December 2019. Now, what are the special features? It's a wireless standard for 4G. It's a type of wireless MAN. It was first time tested by Nokia in 2006 and finalized in 2008 after a successful demonstration of voice over IP by Ericsson. Supports 100 megabit per second downlink stream and 30 megabit per second uplink stream. Highly reduce network latency, and has a capability of backward compatibility, by the way. It has backward compatibility with older technologies such as GSM, okay, or UMTS and others. LTE technology correspond to two lower layers OSI, which is the physical and data link layers. And of course, the upper layers of LTE technology support standard TCP/IP. Now, uh, the wireless local area network, very popular. We all have it at home. Okay. It uses something called CSMA-CA, carrier sense multiple access with collision avoidance technology. Now, what is this? The CSMA-CA is designed actually to minimize the possibility of collisions between data packets that are transmitted concurrently by different devices in your home network. See, like in this type of technology, a device that wants to transmit data first listens to the network channel to determine if there's another device is currently using this channel. Okay. Now, if the channel is idle, the device can proceed with the transmission. However, if the channel is busy, so guess what? The device has to wait for random amount of time before trying again. Now, this randomization helped to avoid the hidden node problem. When you have like two devices are unable to detect other or each other's transmission, and both attempted to send data at the same time. Now, the coverage area of the wireless LANs considered between 65 to 300 feet. Uh, you know, Now keep in mind that the wireless LAN uses very low power access point, which is the central point of the wireless LAN. In some cases, you could always find the high power access point. The reason behind this, we use it to increase the coverage over a large building or campus. Now, the two major types here we have the mesh or peer-to-peer wireless LAN. Now, in this type, you have multiple nodes connect with each other as peer devices in a point-to-point fashion of connection. So this means that there's no access point. In the second one here, we have multiple point, or centralized wireless network here. Now, this second type is the one we use at home or at work for connecting our mobile devices, smart TVs to the internet. Now, this type of wireless LAN is a centralized network controlled by the central point known as access point. Okay, so obviously, any device connecting to the wireless network needs to communicate with the access point for connection negotiation. Now, if you look at this paragraph, this figure over here, here you can see the IEEE standard 802.11a, B, G, N, AC, AX, and BE. And the year was released, the frequency used, the maximum data rate speed over here. Now, uh, I'm gonna focus on the last three a little bit. Now, the IEEE 802.11 AC, that's the standard in which you find it in most wireless devices. Initially released back in 2014, AC increases the data throughput for the Wi-Fi devices up to maximum of 1300 megabits per second. Furthermore, the AC adds something, I'm sure you have seen it in those boxes, MU-MIMO, which stands for multi-user, multiple input, multiple output technology support. Additional Wi-Fi, and also, there's additional Wi-Fi broadcast channels for 5 gigahertz band. That's why in the box we see multiple channels or multiple 5 gigahertz bands, and support for more antennas on a single router. That again, you will see many of them with many antennas there. Now, the 802.11ax, you will have an access to hypothetically network throughput of, as they say here, between 10 to 12 gigabit per second, and which is 30 to 40% improvement over the AC standard. And I'm sure you know that there's Wi-Fi 6, Wi-Fi 6E, and it supports 6 gigahertz. Now, this type of technology will increase the network capacity by adding broadcast subchannels, upgrading the MU-MIMO, and allowing more concurrent data streams here. And the last one, the 802.11be, which is the Wi-Fi 7, uh, years it released back, will be 2024, maybe 2025. I mean, maybe more. Okay. It because the specification for this part has not been finalized, and it supports this type of frequency and the speed up to 40 giga. That's a huge speed, but it is highly likely that this will become the successor of the 802.11ax. You know, and I mean, you see it for yourself, it will deliver double bandwidth and increased number of streams also. Now, let's talk about the wireless personal area network here. Okay, now, uh, it's very small range network, 10 meters, connects personal gadgets and electronic devices for easy management, efficient use, and better entertainment in the personal space. This is the standard, 802.15 standard. Both types of wireless bands uses 2.4 gigahertz ISM spectrum, which stands for industrial, scientific, and medical, for low power radiation to connect to the devices within, very short range here. Okay. Now, there are two types defined by IEEE, which is the high rate personal area network and the low rate personal area network. Now, by the way, the major difference between the wireless LAN And the wireless PAN network is just simply the power level of the signals. In the later case, the power level is kept very low, so the coverage area does not get interfered with other local area network of the same frequency. Now, a good example of this is the Bluetooth, which is we all use it here. And it's a wireless communication system, operate over short range and require low power. Now, the purpose is to enable wireless communication among multiple devices in very close proximity. A good example, like if you have an iPhone and you have an Apple Watch, they connect through Bluetooth. This type of communication enables controlling devices to make decisions regarding the operation of other devices. It's like when I tell, for example, I send a request to my Apple Watch, that's sort of communication from my iPhone to the Apple Watch. Now, you could have multiple Bluetooth-enabled devices in the proximity connect to the central device in a star topology to form something they call it Pico network or Pico-net. This is small network is very useful for connecting devices of communication, such as mobile phones, cordless phones, printers, speakers, MP4 players, microphones, and so on. Now, what are the main features? Bluetooth, it's very low power RF radio frequency technology. Uh, it supports TCP, UDP, and so on. It supports star topology, point-to-point topology, and mesh topology. Low energy Bluetooth based mesh technology is a new standard for expansion of IoT based network of devices. Now, the ZigBee, it's another category of wireless PAN. It's a standard extensively adopted for IoT ecosystem. Low power, low cost, easy to use technology for different kinds of application in IoT. The IEEE 802.15.4 low rate wireless PAN standard governs this technology, by the way. So what's so special about it? It's okay. It's first of all, it's a packet-based radio communication technology. High high rate wireless PAN technology extensively adopted in IoT environment. Operates in 2.4 gigahertz and 900 megahertz bands. Operates very small even in a noisy RF environment. Highly secure kind of communication, the ZigBee type, because it uses 128-bit advanced encryption standard, AES cipher. Usually the ZigBee network have very low latency, provides greater battery life, and it supports auto-healing feature in which the faulty element is blocked and isolated without causing any disturbance to other elements here. Now, the final thing here is the near field communication NFC used for point-to-point communication like Apple Pay. It uses a wireless frequency of 13.56 megahertz bandwidth. Now, when the antennas of two devices come close to less than 10 centimeters, ideally less than 4 centimeters, the inductive coupling is developed and both devices are connected immediately. Now, it uses it, by the way, it allows data rates of 424, 212, and even 106 kilobit per second. And it's called contactless NFC technology and uses very low power in an active NFC devices, and no power is required in the passive NFC devices. And this will conclude the lecture. Thank you so much for watching, and these are the references used for this video lecture. Thank you so much.